You breathe out around 30,000 particles every minute, and if you walked into the room where these chips are made, you alone would destroy everything inside it. Your body is the single most dangerous thing in a cleanroom, and here is exactly why. The chip in your phone contains features so small that they are measured in nanometers. A human hair is roughly 90,000 nanometers wide. The circuits printed onto modern silicon are smaller than the wavelength of visible light, which means a single grain of dust is not a nuisance. It is a boulder dropped onto a city. When one of those particles lands on a wafer during manufacturing, it does not just ruin a spot. It can short out entire circuits, block the light that prints the pattern, or bury a defect that only appears months later when the finished chip fails in someone's device. To understand the stakes, picture the room itself. A modern chip fabrication cleanroom is the cleanest place ever built by human beings. The air inside is filtered so aggressively that it contains up to 10,000 times fewer particles than an operating theater in a hospital. That level of purity is measured in cleanroom classes. The most critical zones are rated Class 1, meaning fewer than one particle larger than half a micron in an entire cubic foot of air. To reach that, the ceilings are wall-to-wall filters, and the entire volume of air is replaced hundreds of times an hour. The air does not just get filtered, it moves in one direction. Filtered air pushes down from the ceiling in smooth vertical sheets and disappears through a perforated floor. This is called laminar flow, and it works like a slow, invisible waterfall that sweeps any stray particle straight down and out before it can settle on a wafer. So the room is clean. The problem is the person inside it. Every human being is a walking particle factory. You constantly shed skin cells, hair, and microscopic debris. You breathe out droplets. Your clothing sheds fibers. On an ordinary day, one person releases millions of particles every single minute. This is why the gowning process before entering a fab looks almost absurd. Workers do not simply put on a coat. They pass through a sequence of rooms, each cleaner than the last, pulling on a full-body suit, hood, boots, gloves, and a face covering until almost none of their body is exposed to the air. The suit is not there to protect the worker. It is there to protect the silicon from the worker. Every fiber of the garment is chosen because it does not shed. The material traps the particles a body throws off and keeps them from ever reaching the machines. Before they reach the working area, people often pass through an air shower. Powerful jets of filtered air blast across the suit from every direction, knocking loose any particle clinging to the surface and carrying it away. Only then are they allowed near the wafers. Increasingly, humans are being removed from the equation entirely. In the most advanced fabs, the wafers travel inside sealed pods along overhead tracks, moving from machine to machine without a person ever touching them or even breathing near them. To grasp why the industry goes to such extremes, you have to understand what is actually at stake on a single wafer. A modern silicon wafer is a disc about 300 millimeters across, and printed onto it are hundreds of individual chips, laid out like tiles on a floor. Each of those chips can be worth hundreds of dollars, and the highest-end processors sell for thousands. A single wafer of premium chips can carry $50,000 or more of value. One particle landing at the wrong moment can wipe out a whole cluster of those chips at once. But the raw cost of the silicon is only the beginning. A single wafer moves through hundreds of processing steps over several weeks or even months before it is finished. Some steps involve machines that themselves cost more than a commercial airliner. When a particle destroys a chip late in that process, the loss is not just the material. It is weeks of machine time, energy, chemicals, and human labor already poured into that wafer, all of it wasted in an instant. This is why fabs obsess over a single number called yield, the percentage of chips on each wafer that come out working. In a mature process, yield might reach the high 90s. When a new chip first enters production, a huge fraction can fail, and contamination is one of the biggest reasons why. The most vulnerable moment of all is called lithography. This is the step where light is used to print the circuit pattern onto the wafer, and it works much like a photographic projector focusing an image onto film. If a particle sits on the wafer or on the mask that holds the pattern during exposure, it casts a shadow. That shadow breaks the printed circuit exactly where a connection was supposed to form. The chip is finished before it ever leaves the machine. There is a real example that shows how devastating this can be. In one widely reported incident at a major Japanese memory plant, a batch of chemicals or materials became contaminated, and the disruption wiped out a significant share of that facility's output, sending memory prices climbing across the entire market. That is the hidden fragility beneath the entire technology world. The devices that run modern life depend on a handful of factories, where the difference between success and total loss can come down to something floating invisibly in the air. So the extreme measures are not paranoia. They are the only reason the chips exist at all. The suits, the air showers, the sealed pods, and the filtered waterfalls of air are all a defense against a threat you cannot see and never stop producing. The next time you hold a phone or a laptop, remember that the chip inside it survived a place where your own breath would have been a catastrophe. In the war between silicon and dust, the human being was always the enemy that had to be locked out.
If you found this deep dive valuable, hit the like button, drop a comment below on what tech mystery we should decode next, and subscribe to never miss an episode.